Lesson 2.6 talks about combinations of functions and composite functions. So our objectives for this lesson are we're going to find the domain of a function, which we've done before. We're going to combine functions using algebra functions specifying domains. So we're going to add, subtract, multiply, and divide them. We're going to form composite functions. It's where we plug one into the other and vice versa. Determine the domains for the composite functions and then write functions as compositions. Alright, so let's look at the next slide there. It says finding a function's domain. If a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. Exclude from a function's domain real numbers that cause division by 0 and real numbers that result in an even root, such as the square root of a negative number. So remember, we've talked about some restrictions on domain last semester. So remember, domain is all real numbers unless. And we talked about a couple of restrictions, but this one it talks about, first one is if it's a fraction. Remember, if it's a fraction, its denominator cannot equal 0. And then we write out our domain from there. And then the second thing it tells us to watch for is if it's an even root radical. Usually we just really deal with square roots, but it could be any even root, 4th root, 10th root, 1000th root. Anyways, you're going to set that greater than or equal to 0. Now, if something happens and you end up with a combination of the two, so you end up with some fraction with the square root on bottom, then you're going to have to take that square root and you just set it greater than 0, because remember, it can't equal 0. Alright, so there's 3 things there to watch out for. So let's go look at example 1. So example 1 says, find the domain of the function g of x equals 5x over x squared minus 49. Alright, so is my domain negative infinity to infinity? Is it all real numbers? No, why not? Because we have a restriction here. And what is our restriction? We have a fraction. So if we have a fraction, what do we know? That our denominator cannot equal 0. So what's our denominator here? The x squared minus 49. So it cannot equal 0. So we could factor this, or we can solve this using the square root property, which is what I'm going to do here. So let's move the 49 over. And so we got x squared cannot equal 49. How do we get rid of a square? We take the square root. And so therefore we get x cannot equal. Remember, anytime you take the square root, you get plus or minus. And what is the square root of 49? 7. So to help me write out my domain, I'm going to look at this on a number line. So I got positive 7 and negative 7 here in numerical order. I got my infinities on my number line. And it says that x cannot equal the negative 7 and x cannot equal the positive 7. But it means x can equal everything except them. And so I can see here when I do my number line, I can see that I've got 3 intervals. So my first one is negative infinity to negative 7, union, negative 7 to 7, union, and then 7 to infinity. And so there is our domain.